Hello everybody. Today we're going to continue talking about simplifying radicals or simplifying square roots. And I'm going to show you a different strategy. You don't have to use it. But some students in the past have liked it. So I'll show you the new one and review the old strategy. And we'll also talk about multiplying and dividing radicals. So here we have the square root of 160. So let's review what we did on yesterday. So we said you can break up the square root by finding perfect square factors. And one way to do that is just picking any factors you can find. So you have your list of perfect squares. And let's say you thought of 4 times 40. So then, square root of 4 is 2, so 2 times the square root of 40. And then, there's another 4 in there, so 2 times the square root of 4 times the square root of 10. Square root of 4 is 2, so 4 times the square root of 10, and 10 doesn't break into any perfect squares. So that simplified, so in simplest form, is 4 times the square root of 10. You might have also noticed you could have done 16 times 10 from the beginning, and then the square root of 16 is 4, so 4 square root of 10. Now I'm going to show you an alternate method. You may like it, you may not, doesn't matter. You could use it if you like. So the square root of 160. So I'm going to show you could do this with a factor tree. So 160 is, so you could say 16 times 10. And then 16 is 4 times 4. And then 4 is 2 times 2, 2 times 2, 2 times 5. So you break it down into the prime factors. You probably did this a long time ago. And every time you see a pair of equal factors, then that is a whole number. So then we have another pair of factors, so 2 times 2, and then everything that doesn't have a match goes under the square root. So basically, you could think of it this way, that these are all square roots. You just broke it down into little square roots. So square root of 2 times the square root of 2 is 2. Square root of 2 times square root of 2 is another 2. And then square root of 2 times the square root of 5 is under the radical for radical 10. So you can break it down into prime factors in square roots, and then you combine the pairs together to make the whole. So either way works. I actually use a combination of the two if I have to do this. So let's use the old method for square root of 2,000. So we have, let's see, 20 times 100. So then that would be square root of 100 is 10 times the square root of 20. We have to check for a perfect square factor. That's 4 times 5. So it's square root of 4 times the square root of 5, which is 10 times 2 times the square root of 5, 20 square root of 5. And that's simplest form. Okay, now if you like the other method, so let's just break it down into prime factors. 2 times 1,000, 2 times 500, and you can do this in any order. Okay, so now you have square root of 2 times the square root of 2 times the square root of 2, square root of 5, square root of 5, square root of 5, square root of 2. So it's kind of like this foolproof method. Sometimes it takes a little bit longer, but it works every time. So then let's see, let's do the yellow. Square root of 2 times square root of 2 is 2. Let's see, square root of 2 here times the square root of 2 is another 2. Square root of 5 times the square root of 5 is a 5. And then you have a leftover square root of 5. 2 times 2 is 4, times 5 is 20, square root of 5. So there's the other method. I will never require you to use one method or the other, so it's always your choice. All right. Multiplying radicals. So in this unit of Pythagorean theorem, you're going to encounter moments where you're going to multiply radicals. Remember, when you leave it in radical form, that's the exact answer. Once you type it in the calculator, you get an irrational number, and therefore it's a decimal approximation no matter what. So you might remember when you multiply numbers, you can multiply them in any order. That's called the commutative property. So you can multiply the whole numbers first. So you could rearrange this whole thing. It's 4 times 3 times the square root of 6 times the square root of 10. Now the square root of 6 times the square root of 10 is the square root of 60. Now you have to check, can we simplify the square root? Let's see. I'll do this one with the new method. So we have 6 times 10, 2 times 3, 2 times 5. Oh, there we go. So we have square root of 2 times the square root of 2 is 2. Square root of 3 times square root of 5 is the square root of 15. There's the multiplying square roots that we just went over. Oh, and don't forget about the 12. That's out here. So you get 12 times 2 radical 15 is 24 radical 15. And that's simplest form. So let's go over to this one. 5 square root of 3 times square root of 3. Multiply the square roots. You get 5 times the square root of 9. Or you could think of it as square root of 3 times square root of 3 is 3. So 5 times 3 is 15. Dividing square roots. Well, the first one, we're just dividing by a whole number. So you could think of it as multiplying by the reciprocal, or just think of it this way. Since this is multiplication on top, when you divide by 8, you only end up dividing one of those numbers by 8. So we actually just simplify the fraction. 12 divided by 8 is, so divide by 4 is 3, 2, and then the square root of 2 stays on top, and that's simplest form. You could even write it as 1.5 square root of 2. Usually we'll just write it as in fraction form. Okay, and we like to make sure there's never a square root in the denominator. So we always will rationalize the denominator. So for the second one, we have to rationalize. So 4 divided by square root of 2. So yes, it's a correct way to write it, but in the math world, we have this kind of rule where you never have an irrational number in the denominator. And I think the reason is, so if you're comparing answers with somebody, you'll be comparing the same answers. So what do I mean by that? Well, here, let's rationalize this denominator. So what we do, here's the trick. You multiply by that term over itself. So remember, when you find equivalent fractions, you multiply by the same number on the top and the bottom. Well, you multiply by that radical. Now multiply across, because they're fractions. 4 times the square root of 2 over, now square root of 2 times square root of 2 is square root of 4, which is 2. And then we simplify that. 4 divided by 2 is 2 times the square root of 2. So in your calculator, go ahead and type 4 divided by square root of 2. Check your answer. And then multiply 2 times the square root of 2. And you're going to see that the decimals are the same. So if you were working on a Pythagorean theorem problem, and you got 4 divided by square root of 2 as your answer, and then your friend got 2 times the square root of 2. This way you would know you have the same answer if you just put them into rationalized denominator form. So this is the expectation. And you'll do some practice on DeltaMath with that. All right, so here we have 6 square root of 3 divided by 2 times the square root of 2. So again, the trick here is rationalize the denominator. So we're going to multiply the top and the bottom by square root of 2. So that gives you 6 times the square root of 6 over 2 times the square root of 4, which is 2 times 2. So 6 radical 6 over 4. And then simplest form will give you 3 times the square root of 6 divided by 2, and that's simplest form. And then the last one here, so we will rationalize the denominator. 10 radical 3 over 2 times radical 9. Let's simplify that. 2 times 3 is 6. So 5 radical 3 divided by 3. And again, you could always check on a calculator. If you were to type this in the calculator, you would put parentheses around there. But that is simplest form. So remember, email me if you have any questions. You have a DeltaMath assignment. So at this point, you'll have completed both simplifying radicals assignments on DeltaMath. And have a wonderful day.